Hi. So we've been graphing rational functions and finding vertical asymptotes, horizontal asymptotes, x and y intercepts, and using those to help interpret the graphs on our calculator. And we have also worked with transformations from our parent graph, but also when we start throwing in quadratics into rational functions, they change the look of the graph. So we have other types of asymptotes that can occur. We have not addressed, when we are looking for horizontal asymptotes, we've not addressed what happens when the degree of the numerator is bigger than the degree of the denominator. And when that happens, it will not be a horizontal asymptote. It could be a non-vertical or non-horizontal line, which we'll refer to as a slant asymptote, y equals mx plus b. Or you could even have a parabolic asymptote. You could even have a third degree asymptote. All right, so let's get some vocabulary in here. So an end behavior asymptote is really just a broad category. An end behavior asymptote refers to every type of asymptote except a vertical asymptote. So if you remember, intermediate behavior was the way to describe behavior around vertical asymptotes. Vertical asymptotes are in their own category because that's where the function is undefined and the graph will never ever cross a vertical asymptote. So end behavior refers to horizontal asymptotes, slant asymptotes, parabolic, etc. So how do we calculate a slant asymptote? Because a slant asymptote is non-vertical, non-horizontal, and it is y equals mx plus b. So that is going to happen when our degree of our numerator is 1 larger than the degree of the denominator. We will end up with y equals mx plus b, the form of a linear equation or a slant asymptote. So how are we going to actually calculate that? Okay, well, let's take a look at the first example here. So I have a rational function, a lot going on in here. I'm not going to go through, we're going to just focus on finding the slant asymptote. We're not doing everything to this problem. So when I'm looking for end behavior asymptotes, I compare degrees, and here we go. We have the degree of the numerator is 1 more than the degree of the denominator. All right, so how do I get my slant asymptote? Well, as I told you before, long division always is helpful. And so that is how we are going to get our slant asymptote. So think about it. If I have 2x cubed divided by x squared, I'm going to get an expression to the first power. All right, so here we go. I wrote down my numerator divided by the denominator. So what do I multiply x squared by to get 2x cubed? 2x. So come back and multiply that, and then subtract the quantity. Now, I had to scoot the minus 4 over because I had to line up like terms. So remember, subtract. So I'm going to be taking the opposite. So I have 3x squared plus 6x minus 4. What do I multiply x squared by to get 3x squared? I multiply that by 3, and then multiply and subtract. Now, if you take a look here, we do have 2x plus 3, and wouldn't that be an expression with mx plus b for slant? Now, I know we get a remainder, but think about when we're talking about this line. This little remainder is, for math words, is actually negligible, because if I'm looking for the equation of a line, that gives me the equation of the line. So this little remainder does not affect this line. So the slant asymptote will be y equals 2x plus 3. All right, so let's head to example 1. So the first questions are just finding end behavior asymptotes. So I'm going to start comparing degrees. And in example 1a, my degrees are the same. So therefore I take the coefficients of I take my leading coefficient, so that would be 3 over 1, so y equals 3. So I do have a horizontal asymptote. So you've probably made the conclusion you're not going to have a combination of horizontal with slant. It's going to be one or the other. All right, let's take a look at B. So I have this function, and I'm looking just for end behavior, comparing the degrees. Degree of numerator is 1 greater than the denominator, so therefore I will have a slant asymptote. So I'm looking for an equation, a linear equation, y equals mx plus b, something non-vertical, non-horizontal. All right, so how am I going to find that? I'm going to do long division. So if we have, again, I could put in my missing terms here. I probably should have done that. X cubed plus 0x squared plus 0x. All right, so what do I multiply x squared by to get x cubed? I get x. So multiply and I get x cubed minus 4x and then my minus 1. All right, subtract and I end up with 4x minus 1. What am I going to multiply x squared by to get 4x? That would be fractional. So this is like our remainder. And think about this. We do have an equation of a line. Y equals x would be my slant asymptote. All right, moving on to example 3. So we're looking at, we're going to do everything to this problem. All right, so I make my list, check it twice. So first of all, I'm going to find my vertical asymptote. So this is what I should do before I put anything on the calculator. Remember, we're going to find all of our asymptotes. We're going to find our intercepts if possible, and then put it on our calculator and put the pieces together. So in example 3, my vertical asymptote would be x equals -3. All right, now finding horizontal, nope. This is bigger. Numerator is bigger than the denominator, but how much bigger? It's 2 bigger, which tells me now I'm actually going to have a parabolic asymptote. So once again, what are we going to do here? We are going to use long division. What do I multiply x by to get x cubed? That would be x squared. Come back and multiply. Subtract that, and I end up with -3x squared plus 1. What do I multiply x by to get -3x squared? That would be -3x. Come back and multiply and subtract. And then I end up, now I should have put in, and I apologize, I could have put in 0x plus 1 so that I have all my terms lining up. But when I do my subtraction, I have 0 minus a -6x, so I have 6x plus 1. What do I multiply x by to get 6x? That would be 6. So correction on the notes, I don't think I have the 6 on there. All right, so now what do I have going on here? So if I were you, I would graph my parabolic asymptote first. Now, you're not going to be able to graph a vertical line, but graph your parabolic asymptote as a separate equation, okay? You could always do that with a horizontal asymptote. I think it's pretty obvious in our graphs when we have those, but sometimes it's difficult to see the path that the graph will travel along. So if I were you, before putting in your rational function equation, I would put in your parabola. Now, let's put in the rational function equation. All right, so at any time if you need to stop the video and do that. All right. Now, my guess is that if you're looking at my graph and you're like, I don't have this in here, this is why we need to sketch our asymptotes and see how everything fits together, because you're missing part of the graph. Now, how would you know that that is there? Well, if your parabola intersected your asymptote, then it made a section, truly a section for part of your graph to be in. All right, so sometimes when you have, or I would recommend when you have a parabolic asymptote to put that in and then put your equation in. Now, you can always go to your table, so if you're concerned about, all right, how would I know this? Look at your table. You will have values less than -2. So that will tell you to adjust your calculator. If this were all an error below, you know you wouldn't have any part of the graph. But if you have values below -2, you know there has to be part of the graph. Okay, oh, and I forgot to mention, I did do the y-intercept. The y-intercept was 0, 1/2, putting 0 in for x. If I tried finding the x-intercepts, that would be ugly because it's a cubic equation. So remember, do those if you can. All right, so now let's describe behavior. As x approaches 2 from the left side, y approaches infinity. As x approaches 2 from the right side, y approaches -infinity. There is not a left or a right. So when you have a parabolic or anything, a slant asymptote, there's no way to describe behavior because they have curves in specific direction. All right, and I also want you to note that this graph did cross the parabolic asymptote. Remember, end behavior asymptotes are not where the graph is undefined. They are just boundaries. So if you notice with your parabolic asymptote that the graph does travel along the vertical and then along the parabolic. So at this one, you may need to play around with on your calculator. If you need to stop the video, do so. All right, let's do one more and let's do everything to this. All right, so we're going to go down to example 4. So I have this function, x squared minus 2x plus 3 over x plus 2. We're going to do everything to this. So first of all, I'm always going to look for my vertical asymptote. Happens to be x equals negative 2 again. All right, comparing my degrees. No, there will not be a horizontal because the degree of the numerator is one bigger than the denominator. One bigger means I'm going to have a slant asymptote, or in other words, I need to find the equation of y equals mx plus b. All right, so I would like you to stop the video and I would like you to actually calculate the slant asymptote by long division. All right, so if you did your long division, you end up with x minus 4. So y equals x minus 4 is my slant asymptote. Again, we're going to get a remainder, but because we already have an expression for a line, that little remainder doesn't impact the line. All right, so just like we've done before, oops, I forgot, I want to find my y-intercept. So if I put in 0 for x, I get 3 halves. So this is crossing at 0, 3 halves. My x-intercept, I could actually set this equal to 0, multiply both sides by x plus 2. I would get a quadratic, but this actually would give me imaginary answers. So that tells me there aren't any x-intercepts. All right, so remember we sketch what we have before we put this on our calculator. So I put in my vertical line, graph that accurately. I put in my my slant asymptote. Now, before you put this into your calculator, you may want to go ahead and put the equation of the slant asymptote in there to see how your curves fit together. All right, now again, I'm going to encourage you to stop and put this in and then compare what you got to what I got. So again, my guess is that you have this part of the curve, but this part of the curve is not showing. If you have two asymptotes intersecting, they have created, for lack of better words, areas for the curves. So again, something that you can also do is look at your table and look below negative 2. If you've got values there, which you will, that's going to tell you have a graph down here. So that's going to tell you to adjust your y-axes. So we have now talked about every type of asymptote and intercepts, and also knowing that we need to do all those calculations first before we put this on our calculator.